Good day, students. Welcome to the review series to help you ace your AP Calculus exam. In this installment, we're going to be going over the solutions to problem 1 of the 2014 AP Calculus AB free response question. This question focuses mainly on mathematical models, average rate of change, average value of a function, and using linearization of a function to approximate the function. Don't forget to visit math.serve.com on the AP Calculus for the remainder of the review clips for this installment. All right, let's take a look at the A part of question 1. It says, grass clippings are placed in a bin where they decompose. For 0 less than or equal to t less than or equal to 30, the amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 to the t, where A of t is measured in pounds and t is measured in days. So question A says, find the average rate of change of A of t on the interval 0 to 30. Indicate units of measure. Okay, so let's write down what the formula is first. Formula. The average rate of change of, let's say, a function f on an interval AB is f of b minus f of a divided by what? B minus a. It's basically the slope of the secant line. That's what the average rate of change is. So in this situation, we have the interval a, b is equal to 0 to 30. And our function is this model right here, A of t, which is equal to 6.687 times 0.931 to the t. So the average rate of change of A of t on the interval from 0 to 30 is simply A evaluated at 30, that's f of b, minus A evaluated at 0, f of a, that entire expression divided by b minus a, which is 30 minus 0. Okay, so let's go ahead and figure out what that is. All right, so I'm going to be making use of TI-89 titanium. Now what I'm going to be doing is I'm going to define my function. I'm going to call A of t f of x, okay? So I'm going to press second function home to give me the custom menu items. And what I'm going to do is I want to store this value into my function f of x, okay? So I'm going to do 6.687 parentheses 0.931 raised to the x power. I'm going to store that in f of x. Okay? Alright, so it's done. So basically I'm going to call A of t is going to be f of x. Alright, so let me call it back. F of x is A of t, okay? So 6.687 times 0.931 raised to the x power. Okay, so to easily calculate my average rate of change, all I'm going to do is compute parentheses f of 30. Remember that's A of t, okay? Minus f of 0. That's my numerator. Close it. Divided by 30 minus 0 is just 30, so divided by 30. Diamond enter to get the approximate result, which is negative 0.197 to 3 decimal places. Okay, so let's write down our answer. It's negative 0.197. We also have to indicate the units. The independent variable is time. What is the time difference here? Go up in days, so it's measured in days. A is the amount of clippings, okay? So negative 0.197, 197, see what is pounds. Okay, yeah, pounds, that's the amount. Pounds of clippings, per day. All right, so this is the answer, but we're also asked to indicate the units of measure. So it's negative 0.197 pounds of clippings per day. Okay? All right, let's take a look at the B part. The B part says find the value of A prime, instantaneous rate of change at t equals 15, A prime of 15. Using correct units, interpret the meaning of the value in the context of the problem. Okay, so let's see. A prime of 15 just simply means that you want to find the derivative, d dx, evaluated at x. I'm sorry, it's d dt. So we want to find the derivative d dt evaluated at t equals 15 of the function a of t. Okay, so all we just have to do is differentiate the function and plug in 15. But since we can use a calculator here, we don't have to work too hard. We can simply take full advantage of that. So what I'm going to do is I'm going to, let's see, I'm going to enter this in the calculator. So all we just have to do, we already have, remember we defined f of x to be our a of t. Let's call that back again just to refresh your memory. So if I call back f of x, that's our a of t function, okay, but I'm using x this time. Now, if we want to find the derivative, we can just simply find the derivative of the function, of this function. The independent variable is x. And then after finding the derivative, we want to evaluate the answer at t equals 15 or x equals 15 in this notation I'm using here. So you simply use the bar x equals 15. So let's take a look at this expression. What this does is it calculates the derivative, d dx, of the function, and then when it's done, it evaluates it at x equals 15. Okay, so it's going to put that in. That goes our answer. To 3 decimal places is negative 1.64. So our answer is negative 0.164. And the units is pounds per day. Pounds of clippings. So the question now is, what does this mean? Let's interpret this answer in the context of this problem. So what this solution simply means is that when t is equal to 15 days, okay, when t is equal to 15 days, the weight of grass clippings is decreasing, right? Because you have the negative derivative there. So the weight of grass clippings is decreasing at a rate of 0.164 pounds per day. Okay, so that's the meaning of the solution that we just got. All right, let's take a look at question C. It says, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clipping in the bin over the interval 0 to 30. Okay, so the time when the amount is equal to the average amount. To find that, to find the t, what you do is you're going to solve the equation. A of t is equal to a of t average on the interval 0 to 30. Okay, so we're basically finding what value of t makes the value of the function equal to the average value of the function in this interval. All right, so first thing we want to do is solve this equation, find the average value, and then set it equal to the original function, and then solve that for the t that makes the amount of the function equal to the average value. Okay, so let's find average value first. So a of t average on 0 to 30, what is that? Let's see. Let's review what the formula is first of all. The formula for f average on an interval AB is basically 1 over b minus a times the integral of f of x dx. Okay, so that's what f average is. So the average value of this function is simply going to be 1 over, in this case we can clearly see that a is 0, b is 30, 1 over 30 minus 0 times the, okay, I made a mistake in my formula. I left out the limits. This is from a to b. It's a definite integral. Okay, so the integral here from 0 to 30, 0 to 30 of a of t dt. Okay, so we already have this function defined in our calculator, so we're going to take advantage of that. So let's see. So what I'm going to do here is compute 1, multiply 1 over 30, 1 divided by 30 because 30 minus 0 is 30, times the integral of the function. Remember, we already defined this as f of x, so let's call that back up. The function, variable of integration is x, lower limit is 0, upper limit is 30. If I want enter to get the approximate value, we have 2.753 to 2 decimal places. So the average value of this function is approximately 2.753. Okay. So when is this function? At what time does this function have this value? So all we just have to do is we're going to solve a of t is equal to 2.753. What is 2.75? What is a of t? Sorry, remember it's 6.687 times 0.931 raised to the t power. So when is this equal to 2.753? All right, so we can easily do this with a calculator, but before I do that, one quick correction that I want to make here. Since 75264, since I'm still going to be using this value for my calculations, it's better, I don't think it's smart for me to round up, so let me add in more decimal places so I don't throw my answer off. Okay, just putting in exactly as it is in the calculator. We're not done yet, so it's 2.75264. When we're done, then we can round it up. 75264. Okay, so we have 75264. Now what I'm going to do is simply plug this in my calculator. Okay, so let me show you how to do it. So what I'm going to do is I'm going to solve F3 solve. So we press F3 solve when the function a of t, we already defined a of t as f of x, when that is equal to this solution right here. Let me call it back up. When is it equal to that? The more decimal places we have, the more accurate our solution is, right? 75264. So what I'm doing here is I'm inputting the average value I got earlier into my equation. Enter. Okay, hold on. So we have to indicate what we're solving for. All right. Okay, or else we'll get an error message. We're solving for x, right? So comma x. Enter. 12.4148, so it's 12.415 approximately. So t is equal to 12.415 days. Okay, so this is the point in time where the amount of clippings is equal to the average amount of grass clippings. All right, so let's take a look at the D part. For part D, it says for t greater than 30, L of t, the linear approximation, to A at t equals 30 is a better model for the amounts of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. So in this situation, we're basically using the linearization of the function as a substitute for the function just to carry out an approximation. And we're basically looking for the time when the linearization will have a value of 0.5. Okay, so all we're doing here is find the value of t where the linearization is equal to 0.5. Okay, because this is what we're using to approximate the amount of grass clippings remaining. All right, so all we just have to do is find the linearization function, set it equal to 0.5, solve, and that will be that. Linearization formula, L of x. Let's go over the formula again, first of all, and then we'll apply it to this situation. All right, so the formula for linearization, let's write it to the side here. L of x is given by f of a plus f prime of a times x minus a. It's basically the equation of the tangent line with y isolated. All right, so to find the linearization of this function, in this situation, a is equal to 30. So we're going to find the following to set this up. We want to find a of 30. And then we also have to find a prime of 30. Okay, we already have the function defined in our calculator, so we can simply plug this in with ease. All right, so let's go ahead and do that. So we're going to do a of 30 first. A of 30, remember, I already have f of x saved as the function. So all I'll do is compute f of 30. And that is 0.782928. And I also want to find the derivative of this function at 30. So to do that, we're going to compute the derivative of the function, independent variable x, and then after differentiating, we'll want to evaluate it when t is equal to 30 or where x is equal to 30 using my notation here in the calculator, okay? So that's negative 0.5597. All right, I'm going to use, let's see, how about we use 4 decimal places to preserve accuracy? A30 is where'd my calculator go? Let's see, where are you? Is 0.78229. Let's put one more decimal place there, 78293. And then A prime, this is basically the slope of our linearization or tangent line, is negative 0.05598. Okay, to 5 decimal places. All right, so we have all the information we need to formulate the linearization. So the linearization, L of t, in this context is basically a of 30, that was y1, plus the slope, a prime of 30, times t minus 30. Okay, so let's plug in this information in there. So we're going to have L of t is equal to a of 30, which is 0.78293 minus a prime of t. Well, plus times minus is minus, okay, so that's how I got that. 0.05598 times t minus 30. Okay, so this is the linearization. This is what we can use to approximate the amount of clippings left behind. So the question is, when is this approximation equal to 0.5? So all we do is we set this 0.78293 minus 0.05598 t minus 30. We set that equal to 0.5, and we solve for t. Okay, Let's use our calculators to make our life easier here. So this is what I'm going to do here. I'm going to extract these answers one by one. So that value minus, actually just, well, plus parentheses this value right here times x minus 30. Okay, so what I'm going to do is I want to solve when this is equal to 0.5. Okay, I didn't put in all the information, but I'll put it in momentarily. So I want to solve it for x, or you can put t, whatever variable you want. And then let's go back to the front. Type in F3, which is solve. Solve this equation. Press enter, and then your answer is 35.054. You can do this. I'm trying to use a calculator to make my life easier, but if it's too abstract for you, you can do it, the old-fashioned way. You're basically solving an algebraic equation. You subtract this number from both sides, divide by that, and then you add 30, and then you get your answer, okay? So the time when the linearization is going to be 0.5 is when t is approximately 35.054 days. Okay, so there goes your final answer. So thanks so much for taking the time to watch this presentation. Do feel free to subscribe to our channel for updates to the remainder of this review series and other great prep tutorials for the AP exam. And do post a comment to let us know what you think about this presentation. We appreciate it. Do give us a thumbs up if you liked it. More clips